This video is on the ideal gas law. So there is an equation that we can use to calculate with those variables that we've talked about, pressure, volume, moles, and temperature, where they will all equal the same value. When we talk about ideal gases, we're talking about gases that always behave a certain way. Now, do all gases in real life, or real gases as we call them, always behave this way? No, but we can use this to predict how they will behave. So this R value is the one that they will all equal when we put them in this equation. So this R value is what we call the ideal gas constant. So it is a constant, it is always the same value. So for any gas, if you take the pressure of that gas times the volume, and you divide it by the moles times the temperature, and they're not written, but it's assumed. These are in parentheses. We just don't normally write them. So if you take pressure times volume and divide it by moles times temperature, they will always equal this R. And this R is 8.31. And the units are these 4 units. So kilopascals for pressure, okay, liters for volume, moles for moles, and Kelvin for temperature. Okay, so the same value every time. So this is a big deal. I would highlight, circle, star this, but this value is what you need to know for R. You will be given this on any sort of test or quiz, but you need to know what to do with it. Okay, so when it comes to the ideal gas equation, right, this is our equation right here. But it's a little simpler and easier to work with if we put it without the division sign. So if we take N and T and we multiply it on both sides, right? So if I take, right, PV over NT equals R, and I do the algebra to take these two, if I multiply times N times T, right? If you do something divided by itself, it cancels out. If you do something on one side, you do it on the other side. Okay, so to write that, our ideal gas law, what we usually write is P times V equals, and I don't know why it's in this order, but N, then R, then T. And you know that multiplying order doesn't matter. So PIVNERT, sometimes it's kind of said. All right, so here's our ideal gas law equation. All right, so a couple reminders, and we've talked about these, but we got to remind ourselves what they are one more time. P stands for pressure, and your pressure has to be in units of kilopascals. So we reviewed, or we talked about how to do the conversions. Like if it's given in torr, you're going to have to convert it to kilopascals before you can use the equation. V is volume. Volume must be in liters, and the common conversion would be like milliliters to liters. So remember this, right? If you have let's say 5,320 milliliters. How many liters is that? So that's taking right from milliliters right here. You're going 1, 2, 3 to your base unit. So it's taking your decimal and going 1, 2, 3. So this is 5.32 liters. All right, moles, N is moles, right? That is a unit already. We abbreviate it. And T is temperature. And it has to be in Kelvin, right? We measure in Celsius, we calculate in Kelvin. All right, so let's do a problem with this. So it says calculate the volume of 0.0250 moles of nitrogen at 35 degrees Celsius and 780 millimeters of mercury. All right, so the first thing I'm going to do is I'm going to go through and underline everything that I know and to find my unknown. So calculate the volume. Okay, that's what I don't know. So this is my question mark. All right. 0.025 moles, here's N, okay, at 35 degrees Celsius, there's my temperature, right, and 780 millimeters of mercury, that's pressure unit. So just look at the units. The units tell me everything. All right, so now let's write these down also again, but let's do our conversions because some of them, like Celsius here, we have to change this to Kelvin, and we have to change this to kilopascals. Our moles can stay, and our liters will just be in volume, or our volume will be in liters. All right, so let's do temperature first, right? Temperature is 35 0.0 degrees Celsius. So if we're going to go to Kelvin, Kelvin's always bigger. So we're going to add 273. So when we do this, we get 308 Kelvin. Okay, and then our pressure, we've got 780 millimeters of mercury, and we need kPa. So we're going to take millimeters of mercury on the bottom to divide out. We're going to convert to kilopascals, and if you flip back in your packet, you'll find this conversion, but 100 kilopascals equals 760 millimeters of mercury. So millimeters of mercury divide out. If I take 780 times 100 divided by 760, I get 102.63 kilopascals. All right, so I'm going to circle all the things I need. I've got my moles, got my temperature, got my pressure. We always know R, right? 8.31 kPa times liters over moles times Kelvin, right? And here's our unknown, this volume. Okay, so my equation is PV equals nRT. Now you have two choices. You can either plug your numbers in right now, so replace P with this 102.63 kilopascals, do the same with N and R and T, and then solve for V, just like you would in math. Or you can do the algebra right now with the letters and solve for V, and then plug your numbers in once. This is my preference. My preference is to solve for V right now, because when I divide by P here, I'm just writing one letter instead of writing this whole thing 2 times here and here. If I do one thing to one side, I do it to the other. This divides out. So my equation is V equals nRT over P. So I just rearranged everything for my unknown, my question mark, to be by itself. And now I'm going to write my numbers in one time. And I'm going to write all the units with them. That's going to help me see that I did it correctly. So 0.0250 moles, okay, times R, 8.31. And I'm going to write all these units, kilopascals times liters over moles times Kelvin. Remember, I don't ask you to do things you don't need to do. It's important that you write the units. Okay, times the temperature, which was 308 Kelvin. And then this is all divided by my pressure, which was 102.63 kPa. All right, now I'm going to go through and I'm going to cancel units that divide out. So anything that's in the numerator and denominator will divide out. And what I should be left with is my units for volume, which should be liters. This is a way to check. So moles right here, just anything by itself is in the numerator, but this is in the denominator. So moles divides out. Same with Kelvin, numerator, denominator. Okay. Kilopascals is the numerator in the numerator. This is in the numerator of the denominator, so these also divide out. So what am I left with? What I was hoping for, liters. So calculator, I'm going to type in 0.025 times 8.31 times 308 divided by 102.63. And my calculator tells me this is 0.62 liters. And that is the ideal gas law, where you can use this one equation. If you know 3 of the variables, you can calculate the other missing variable, because they always work out to equal, we go back to here, to equal this R value.